Hey guys, I just wanted to give a quick 2-minute summary of the video I made yesterday because I doubt many of you guys are interested in watching a 25-minute video. So let's just turn over here and take a look at what I've got going on. Since the last video, I've gone ahead and I've put the whole thing together. I've been running the machine using the belts. I've got the belts installed. And I switched out this bracket on the corner here, and I did that because the previous bracket was just a little bit too wobbly to feel like I was actually getting a good representation of what was going on. Then I've actually gone from that bracket to this bracket right here, and this is just a little bit more like my final design. But you can picture how something like this would be made out of sheet metal as well. Just fold the edges of the box in. Alright, so running the machine, I was able to tune it up to 1,000 millimeters a second. But doing some more research, I had heard hearsay that 1,000 millimeters a second was top of the line, and it was not actually. More like 5,000 millimeters a second. 1,000 is more like the best you could get out of a really budget laser. And so the top of the line lasers are actually running at more like 5,000 millimeters a second and 5G acceleration. So I went ahead and did some math and based that on the inertia of the system. So you got to calculate the inertia of your rotor. Hopefully some of that's given to you. The inertia of the rotor and the inertia of the rest of the system. The cart that's moving back and forth. And I am going to run it at 5,000 millimeters a second with 5G acceleration. At least that's the plan. The thing that enables me to do that is that I went ahead and I bought a servo motor. Servo motors are a closed loop system, which means that the controller not only tells it what to do, but it tells the controller what it did. And that gives it some benefit. It doesn't need to have the discrete stepping that a stepper motor does. It can move. It can just spin and have the feedback tell it where it's at and adjust accordingly rather than simply depending on the signal sent is what it did. So it has a lot better performance at higher speeds, and that's what I'm trying to get out of the laser cutter. So I can run the laser at higher speeds. Now it looks like one of the next things to do is I'm going to build a cardboard model of the whole machine, or at least I'll get started on one and see how far that gets me. I've got the water cooling being worked on. Hopefully I'll give you an update on that as well. So that's all, folks.